All right, let's dive in. Today, we're going to talk about the very foundations of how software gets made. I mean, way before things like agile and sprints and constant updates became the norm. Back then, there was a totally different philosophy. It was all about bringing predictable, stable order to what was, frankly, the wild and chaotic world of software development. So the big question is, how did they first try to tame that chaos? And this quote, man, it just hits the nail on the head. See, building software isn't like building a bridge. With a bridge, you know your materials, the physics are set, it's predictable. With software, the materials are ideas, and the customer's needs can change halfway through the project. So the very first software engineers tried to fight this chaos by forcing a super rigid, super predictable structure onto it. That really was the million-dollar question. I mean, think about it. If you don't have a map, you're going to get lost, right? But what kind of map can you possibly draw for a landscape that's shifting under your feet? Well, their first answer was simple. Draw a very, very straight line. And that brings us right to our first stop, the idea of creating order from software chaos. The thinking was, if the process is wild, let's tame it with a set of prescribed, structured rules that every single project has to follow, no exceptions. They came up with these things called prescriptive process models, and the name is perfect because just like a doctor's prescription, they told you exactly what to do, when to do it, and in what order. The goal here was super clear: stability, control, and organization. You can almost think of it as a step-by-step recipe for building software that promised a perfect cake every single time, as long as you followed the instructions to the letter. Now, this whole philosophy led directly to the most famous, or maybe infamous, prescriptive model of them all, the Waterfall Model. It's pretty much the oldest paradigm in software engineering, and its logic is, on the surface, incredibly easy to understand. The name really says it all, doesn't it? The core idea is that work flows in one direction only, down, just like a waterfall. Each phase has to be 100% complete before the next phase can even begin. And there's no going back. You can't swim back upstream. Once a phase is done, it is done. So here are the 5 distinct phases of the waterfall. It's this perfectly clean, linear progression. You start with communication, then you move to planning, then modeling, then construction, and finally deployment. Each step is its own little world that has to be finished and signed off on before anyone can even think about the next one. So that first phase, communication, is absolutely critical. In a pure waterfall project, you have to get every single requirement from the customer before you do anything else. I mean everything. The entire project is built on this assumption that these requirements are set in stone and they will not change. Then, after you've planned everything out, you get to modeling. This is where you create the complete architectural blueprint for the software. And the key thing is the design has to be perfected on paper before a single line of code gets written. There's no room for improvising later on. And then, after all those other steps are finally done, you get to deployment. This is the big reveal. This is the very first time the customer sees the actual working product. All that work, all that planning, it all leads up to this one single moment of delivery. I mean, on paper, it sounds perfectly logical, right? A disciplined, step-by-step process. But what happens when this perfect, clean model meets the messy reality of an actual software project? Well, that's when you start to see the cracks appear in the waterfall. Exactly, because the real world is never a straight line. Customers realize they need something new, the market changes, a better piece of technology comes out halfway through the project. Suddenly, the strict linear nature of the waterfall model feels less like a helpful guide and more like a rigid cage. And people pretty quickly identified 4 massive problems. First, like we just said, real projects are almost never linear. They need you to go back and tweak things. Second, it's basically impossible for a customer to know everything they want at the very beginning of a project. Third, it creates a ton of wasted time for the team. And finally, that big reveal at the end, it's incredibly risky. This brings us to a huge issue called the blocking state. Because the process is so sequential, you have developers just sitting around, waiting for designers to finish their work, and the designers are waiting for the final requirements to be signed off. Some studies found that the amount of time team members spent just waiting for someone else could actually be more than the time they spent doing productive work. It was just incredibly inefficient. But the biggest risk of all, the one that could truly kill a project, is this: Because you don't have a working piece of software until the very end, a fundamental mistake, a misunderstanding from phase 1 might not be discovered until phase 5, and by then, fixing it could be catastrophically expensive or even flat out impossible. So, this massive risk, the total lack of ongoing testing and validation, led to an evolution in thinking. It wasn't a completely new model, but it was a really smart variation that tried to fix one of Waterfall's biggest weaknesses. And this is where we meet the V-Model. The brilliant insight of the V-Model is that testing isn't just something you tack on at the end. Instead, it explicitly pairs every single development phase with a corresponding testing phase. This makes quality assurance something you do continuously, right from the very start. And you can see the core idea right here. It's all about symmetry. As you move down the left side of the V, the development stuff, you're simultaneously planning the tests on the right side. So, for example, while you're gathering the requirements, you're also planning the final acceptance test to make sure what you build is what the customer actually asked for. When you're designing the architecture, you're planning the system test. It's this beautiful, parallel process all the way down. So the real takeaway here, the big light bulb moment of the V-Model, is that it completely reframes what testing is. It's not just about finding bugs in the code anymore. It's about verifying that every single step of the process, from the initial idea to the final architecture, was done correctly and actually meets the goals of the previous step. So, when we look back, what's the legacy of these prescriptive models? Well, you have to give them credit. They were the first real attempt to professionalize software development, to try and turn it from this chaotic art form into a disciplined engineering practice. And to sum it all up nice and neat, the classic waterfall model is all about that simple one-way street, that linear progression of activities. The V-model is the evolution of that, putting a huge emphasis on the critical symmetry between building something and, well, making sure you built it right. And, despite all their flaws, we shouldn't just toss them in the history bin. There are still situations where they can work. If your requirements truly are fixed, if they are well understood and not going to change, maybe it's a government-mandated update or something, this kind of disciplined linear roadmap can actually still be incredibly effective. But all of this leaves us with one final big question. These old models were designed to provide order, and order creates stability. But the modern software world is defined by constant change. So what happens when the most important thing isn't following the plan perfectly, but being able to adapt to the unexpected? Well, that's a story for another time.